So we were at the friction. We were discuss about some types of friction, that was static friction, and today we will discuss about the limiting friction. Limiting friction. First of all, if we talk about the static friction, we have taken the example that suppose that this is a surface and this is a mass of 5 kg. Suppose that, right? And this is a, we can say, applied force, that is a 8 Newton, and this is a, we can say, static friction, that is also the 8 Newton. So the, if we talk about the maximum value of the static friction, that is the 0.2. So the static friction, so the body, this body will be in the rest. As before I've discussed, that if this uh, static friction and the value of applied force both are equal, the body will be in rest. After that we have see that for example this is surface, and after that we have applied the force of 9 Newton. So the static friction will be also 9 Newton. So this body will be also on the rest. Now suppose that this is a surface and this is the same body, there is a 5 kg, right? After that, suppose that this static friction, that is a 10 Newton, and this applied force is 10.0001 Newton, and the mu s is equals to the 0.2, right? So this body will be in the motion, because you can see here these both are not equal. This is 10 Newton, this 10.0001 Newton. So here we have we will see that 0.00, it's also matter in the friction, that if we apply the 10.0001 Newton force on it, so it will start moving, that so this object will start moving, because the static friction force, that is a 10 Newton, and this applied force is a we can say 10.001 Newton. So this is a more force than the static friction, so this body will, we can say, tend to motion, will start to motion. So what is the, we can say, example definition of the limiting friction, that we take that limiting friction is the maximum, it's the maximum opposing force that comes when one body is just started moving over surface. Limiting friction is of maximum opposing force that comes when one body just started, it's still static force, because of we can say that this force, applied force, less, we can say, more than the static friction, so this body will start, we can say, started moving over the surface. So that is called the limiting friction. Before, in the static friction, we have discussed about that if F applied force is more than the Fs max, this is a maximum value of static friction, because this was a variable, static friction value was a variable, but static friction maximum value was a constant. When this will be, we can say, more than this, so the body will be in the motion. Here this Fs max is, we can say, replaceable by the limit F limiting. This is we can say reflexible by the limiting friction. It's only replaceable. Limiting friction is same as the maximum value of we can say static friction. As before we discussed about what was the value of the we can say static friction maximum value, that was F maximum, that was equals to the, that was a mu s and n. This was a Fx maximum value. So this Fs maximum is only replaceable by the Fs limiting, because in maximum value we have also seen that the body will start moving. In limiting friction, it's seen the body will start moving. So the F limiting will be equals to the, this one same, but only Fs maximum will be changed by the Fs limiting. So by this formula we can find the value of limiting friction. After that, if we talk about the another type of the friction, that is the kinetic friction, right? Kinetic friction. Now what is the kinetic friction? Basically kinetic friction occur when the relative motion is there. When relative motion is there, which means the motion is there, then this kinetic friction will occur. This is a simple type of friction, that if a friction produce, this friction produce kinetic friction produced when the bodies are moving. When the bodies are moving, then this kinetic friction is produced, which means if the bodies are in the motion, then the kinetic friction is produced when the bodies are in the motion. This kinetic friction is a constant friction force. It is having constant value, right? If we talk about this, that F kinetic is directly proportional to the normal reaction, right? So the Fk will be equals to the mu k, and this is a mu k, it's a friction constant. So by this formula we can find the value of kinetic friction. So that was a kinetic friction and that was a limiting friction.